Hello, this time I want to show you that sometimes a complex physics problem can be solved in an easier way. So our characters today are four kids whose names are A, B, C, and D. And they are playing a game. So each of them stands at the corner of a square with length of side L. And the rules are A is going to chase B, B is going to chase C, C is going to chase D, and D is going to chase A. They start at the same time and run with the same speed v. So the question is, how long does it take for four children to catch their target? So let's envision the situation first. When they are running, their direction is always changing. And I believe that you can convince yourself that all four of them will run into each other in the end. So how do we approach this problem? Let's assume that after time t, they are standing at four corners of a new square, which is the right one on the screen. If you ask why it's still a square, I would say that because their speed is the same. So this triangle here, this one, and this one, they are congruent. So let's come back to our problem. As you can see, after a small amount of time, they change their direction. And when we are analyzing objects' motion, we will never ever want to deal with curves, especially when they are irregular. The context gives us speed and asks for time. So what we need is distance, because distance equals to v times t. You probably can use calculus to figure out the exact distance for each kid, but we're not going to do that because it's too complex. In order to solve for time, we definitely need speed and distance. But we cannot use speed v because we cannot solve for its distance. So let's find a substitute for speed v. As you can imagine, at the end of the game, all of them will run into each other at point O, which is the center of the square. And velocity is a vector. Displacement is also a vector. So let's say what portion of speed and what portion of displacement can we use to solve this problem? It is pretty interesting that they always stand at the corners of a square, which makes me think that we can divide velocity into two directions. One is towards the center of the square, and the other one is perpendicular to that, which is v sine theta. And the magnitude of the portion towards the center of the square equals to v cosine theta. Because this is a square, so it is not hard to find that theta equals to 45 degrees. So we can calculate that v cosine theta equals to square root of 2 over 2 times v. And the displacement traveled in this direction is amazingly simple. It's just from Q to D, which equals to L times square root of 2 divided by 2. So we simplify the direction changing situation, and time t equals to our new displacement over our new speed, which is L over v. So the big idea is, by treating them as vectors, we can simplify the problem by working in different directions, which is the same reason for free body diagram. And thank you for watching.